only thing I've done is read the freaking code. Graphite is not that bad to read through. It's all Python. It's pretty easy to follow. So I do encourage people, if you have questions, feel free to ask me. I'm on the IRC in Graphite, but generally all I'm doing when I answer your questions is I'm going and looking in the code, and if I don't know offhand, I'm figuring it out myself live as you're asking me. So I do encourage people to do that themselves, just because it's a great way to learn the project as well as the problem space. Graphite has a lot of funny little edge cases all over, and there are reasons for those. Not that we can't deal with them, but it helps your understanding to actually go through and see why some of the choices were made, and some of the trade-offs. So we're talking about time series data here. So time series data, as Graphite knows it, this is what the time series looks like in the web app. It's basically just a list with a few properties here. So the length of the series is determined by the step between the data. So that's say 60. If your step is 60, that means you have a data point every 60 seconds, and then you know how long, how many data points you have, because your duration divided by your step is going to be the number of values that you actually have. And the reason to do this bucketing is mainly because it's convenient. It makes it easier to deal with the data, and easier to do things such as consolidation, which is what we're primarily going to be focused on here. There's another way to look at the time series is as just a pair of timestamps and values. And here still we're talking about time series that's evenly spaced with a step. The reason I want to talk about consolidation is because I feel it's one of the more confusing aspects of dealing with Graphite. Partially because some of the choices, the implementation choices, because a lot of the properties are not exposed directly to the user at the moment. So you have to. It helps a lot in using the system to know what you're actually dealing with, as far as how the consolidations roll up, and how that relates to the actual data you're storing. So I'm going to start with a little bit of an overview of Whisper. So Whisper is Graphite's format for time series data. People who have been paying attention for the last couple of years know that we're also talking about a new format that continually gets delayed for arbitrary reason, but we're not going to touch on that right now because Whisper is what everyone's using right now. The history of Whisper, it was an instance of hate-driven development back when RRD was a lot worse than it is now. This is before RRD cache D, and back when RRD could only write a single point at a time, so IO hell was very common. This was written by Chris Davis, as well as the rest of the project, and it was written over a weekend. So he made a lot of choices that he now regrets. But most of us, I think, feel it's actually not too bad. There are reasons he made the choices that he made, and it simplified the implementation much. Some of the choices. So we have round-robin database, so it means it's fixed size. What happens is points are at a predictable offset. So when I have a file that has a year's worth of retention at 60-second resolution, I know that if I store a point from 1 month ago, I know exactly where which offset in that file that data point is going to be placed. And so the way nuns are stored is actually a bit of a hack. Every data point in Whisper is the timestamp and the data point, and if the timestamp doesn't match the timestamp you requested, that's a none value. So that's why we don't have to actually record nuns when we roll over. We just know that nobody's updated that data point since we last rolled over. It's the old data point from a year ago or something. We know that that's a none. And as most of you probably know, newer data points do overwrite the older data points. We don't do any sort of aggregation within the file like RRD does. What you store is what's in the file. The biggest, so what everyone does know who set up Graphite is you always set up a storage schema, and that determines what archives you have. So archives are actually what you're configuring when you're configuring your precisions and retentions. And the big gotcha is that every archive starts at now, and everything in Whisper is relative to now, which is one of these choices that simplifies implementation greatly. When we look at the archives, this is actually how they're laid out. We have every archive starts at now and goes to whatever its retention is. So a common misconception when people start working with Graphite is that when you configure, in this example, we have our first archive has 10-second precision for 60 days, and then has 60-second precision for 180 days, and then it's got a yearly retention as well. So the assumption oftentimes is that this is a 60 plus 180 day plus 360 day retention, but that's not actually true. So what happens is all the archives start from now because they're all updated at every update. So when we write a point, we're actually updating every archive. We're updating the first archive, and then we're rolling down and doing that consolidation at every update. So the one thing that influences that roll-up is the X-Files factor, which is one of the most confusing terms, but the name actually comes from RD. It was not Graphite's invention. And it's what determines whether that roll-up occurs. And the idea is that none values are actually important to see. It's important to know when you don't have enough data to display. And if you have, say, I tend not to recommend such long roll-ups, but if you have, say, an hourly roll-up, you perhaps do not want to display a data point if you had one data point in that hour. If the rest of that hour is empty, you may want to display that as empty. There may not be enough data for you to actually consider that roll-up valid. But so this is what actually controls this value. The default is 50%. So 50% of the values. If 50% of the values are present, they'll get rolled up. And so we have here these buckets here. So I don't have a pointer, but so we see here these are, for instance, 10-second buckets, which is a common retention. So in this first minute, the bottom of the minutely roll-ups, in the first bucket, first set of buckets, we have every value satisfied, and that rolls up to an average. This is default average of 2. Whereas the second group, we don't have 50%, so we actually don't roll that up. So because every archive is rolled up at every write, and because previously written data points need to be read to roll up those archives, more archives actually means more I/O per write. In practice, this tends not to be too bad, but you should be conscious of this as you decide on your storage schemas. I want to discourage people from using them a little too much. I do see some crazy ones out there. So generally, what we want to do is we want to choose them to reflect how often we can send data and how long we're willing to wait in between graphs. Everyone would like secondly data, but consider, if you're running something that is doing your data collection and you're collecting data from say your web server, you're doing some kind of check and making a timing on a live HTTP check. If you're doing secondly data, you better be sure that those timeouts are going to be under 1 second, and it may not be desirable to have secondly data in that case, because you have to consider the case where your checks might take longer than your actual retention. Most commonly, people choose either minutely or 10-secondly. 10-secondly is kind of Etsy's famous, someone correct me on the title, Measure Anything, 2011 blog post on how they use Graphite. They laid out their storage schema where they use 10-secondly data, and that's the default for StatsD. Minutely is nice because it's a nice intuitive value when you look at things from minute that makes sense to people, and also consider how long your day is useful for, because these are statically sized files because they're round robin, and people would love to have their data last forever, but in this case it doesn't make sense to make them as long as possible, because if we have a 5-year retention we set on all our metrics, we're using that space up front, and you need to be balanced as far as how you decide to use your space. So here's the balance here. Balance on how much disk space you have and at what point the lower precision stop being useful. So I see people sometimes do daily roll-ups. Personally, I don't feel a daily roll-up of values is very useful. We don't store any other information when we do these roll-ups. We don't store any percentiles or anything that would kind of give you some hint as to the distribution of this data. So you've really lost a ton of information if you're going as far as daily. And if something useful something is useful on a daily basis, and it's not worth it to store it at a higher granularity, then you perhaps want to consider other data sources. So if you're looking at like your daily sales or something like that, you probably don't want to use a daily roll-up for that, because it's likely to not be accurate, and it's not really useful for anything else other than looking at what your sales were for that entire day. And you should probably be pulling that from a live data source like your database if you're doing longer. If you're doing some kind of long-term report where you do actually want that accuracy. And I'll note that Graphite's focus is on trending. So when you're looking at daily roll-ups, it's hard to actually spot trends. So I do recommend sticking with a single retention, just because you don't have to deal with a lot of what I'm about to talk about here. And it tends to be a lot more simple to understand and reason about for both the people putting data in and viewing the data and recording it out. If you tell all of your users that you have minutely data and it's just minutely data for the next year, that's very easy to understand. You don't have to understand really anything beyond that as far as how your data is pulled. So if you do choose multiple archives, so here's an example. I've seen stuff like this in the wild. Just think about it. You may choose to do this, but know what the trade-offs are when you choose to do retentions like this. I think what is most optimal is if you're doing multiple retentions, do 2 retentions, maybe 3. So do your 10-secondly and roll up to minutely, and store those minutely's for a year, something like that. This actual second statement, after some conversations today, I'm not quite sure this is only true actually in the case where you have more than 2 retentions. So that second roll-up, the reads will always happen, because we need to know whether we have 50% of those data points or not. So when you have more than one retention, you will always read as many data points as roll up into that second retention at every write. And this is one big caveat as far as usage. So this is the behavior of the Graphite web app, and it comes all the way down to Whisper. So Whisper, we're talking about evenly spaced data in our time series. And so Whisper, when we request the data, because we have data from now until whatever the end of our retention is, it's going to pull from the archive that is most appropriate to pull for based on that retention. So if we have, from our previous example, we had our first archive went back to 60 days time. Well, if we request 61 days, we're getting that second archive. And so because of that, we have to understand how the consolidation and aggregation works. So in this case, generally refer to this part as aggregation. So we have an aggregation method that we configure. So the use case for this in general is because, the first case is to course our data into these actual buckets. And this is something that Graphite doesn't actually deal with. This is something that StatsD does, and this is something that, say if you have a library, say in your Java app that sends to Graphite every 10 seconds, it's doing this consolidation. If you have your operating system is recording counters, that's a form of aggregation. We're polling, if we're polling counters, say with collectd, we're polling at 10-second interval. Well, we're polling pre-aggregated amounts there at that point. Something is actually like keeping count at every action that drives these metrics. The motivation we have here is usually to save on storage space in Graphite's case. The reason people don't do 10 seconds forever or 1 second forever, I can't remember what 1 second is for yearly. It's something like a few hundred megs. It's 12 bytes per point. So generally people, even if they're doing 1 second metrics, they'll use this to save on storage space. And we also, at display time, we need to fit a lot of data on the graph sometimes. So 1 year's worth of points at even minutely points, that's a lot of data points. So we don't really have that many pixels to be able to display that many data points without it looking quite messy, which I'll show. So we default on average for basically everything. It's average is what people generally think of first when they think of consolidating data. And it's basically a sane default. For trending, average works just fine. I mean, you lose your outliers, and that is sometimes important. But it does work with most data points. And if the most common split between metric types is between things that you want averaged and things you want summed. And so this is why StatsD's two core types are a count and a timing, because your timings you're averaging, and StatsD is also taking some extra distribution metadata there, and your counts you're summing. So since we know how many points go into each rollup, if we need to, we can calculate the actual sum. So we had 10-secondly data going into minutely data. That's 6 data points. So if we need to calculate our sum, if we mistakenly averaged when we rolled up to our 60-second data, we multiply it by 6 and we get the sum back, because all we did was sum them and divide by 6. So here are the aggregation types that Graphite knows about. So average, sum, min, max, latest. The most common, so average is the default, so it's the most common. Sum is also very common. Min, max, and latest are a little bit less common. And so I'm going to go through each of these types and come up with some examples of data that you tend to bucket in each type. Now, I would like to get on each type people to think about their data, and if you see something missing, shout it out or give me feedback and say you don't like this. This is all very subjective. These are decisions that you make that I want you to make conscious of what the implications are as far as how your data is going to be displayed and viewed. So plenty of people are fine averaging their counts and just knowing they'll have to multiply if they need to actually get a discrete value out. But for many people, that's not intuitive, or it's not intuitive for their users. So here, I'm sure I'm missing some stuff, but for average, so latency measurements we've already talked about for StatsD. Gauges, I think most of the time make sense in average. So think about like the load average of a server. If you're looking at the load average of a server at 10-second samples, and then you want to roll that up to minutely samples, you probably want the minutely average then of that. Now, load average actually in particular could be a little more tricky because you're already looking at averages. You're looking at the 1 minute, 5 minute, and 15-minute averages. So there are other ways you can interpret that. Rates in general are a little confusing, and I have a little more to talk about rates, but rates in general make sense to average. Now it's a little bit tricky because rates are actually, when you're looking at a count, so you have your count per 10 seconds, that is a rate itself, but I'm talking about those a little bit separately. So I'm saying like a rate is an actual, I've somehow received a per second rate or a per minute rate. So something else has decided on the unit of that rate in this case. And then min-max percentile, I have these listed in other categories as well, but it could make sense to average these. So if you're looking at your StatsD min and max, your upper and lower, it could perhaps, go ahead. No, go ahead.
With regard to rates, you actually say something else. With the word rates, that the title is averaging. So when you talk about averaging rates, what do you mean?
So let me give a concrete example. So most of our users are using StatsD, and one thing that actually, I'm not sure whether the latest version has changed this or not. But one thing that StatsD does that is confusing to a lot of new users is that when you have, say, a 10-second flush interval, which is the default, it's doing 10-second aggregates of whatever is being sent to it. When you send it counts, it divides those counts by 10. And so you get a per-second rate. So people are like, well, I sent 10 to it, and I got 10-second, I have 10-second resolution, so why don't I see 10, why don't I see 10 on my graph? Why do I see 0.1? And so it's because they're deciding that a per-second rate is more intuitive. And so actually, I'll skip ahead if you don't mind. So I would love to be corrected on this. I don't find it quite intuitive myself.
Let me just make a comment. I'm not really sure what you're saying, but just something to watch out for.
Mm-hmm.
This is just a global comment. I don't know, maybe it'll come to it later, but so there's averaging, like averaging numbers or counts or whatever. That's one thing. But when you're averaging rates, which are inverse time, if you remember my pre-economics metrics, you would be very careful. You can't take the arithmetic mean. You have to take the harmonic mean, or you're going to get to the big trouble. So rates do not average like other types of metrics. Put it that way very simply. We can pick that up later.
So rates don't average like other types of data. And I think that's probably where I have run into. I struggled with I've always struggled to kind of understand this, and I think that's maybe what I'm sensing is that I don't fully understand this.
So the usual averaging means arithmetic mean.
Right.
Just sum the numbers and divide the number of numbers.
Right.
That's also true for the normal statistical mean. That's what we're actually talking about in general.
Right. Right, and that's what we're doing. That's what this averages is an arithmetic mean.
Pretty much all statistical tools that refer to a mean or an average
Right.
are doing an arithmetic mean. And therefore you don't run into this in the normal statistical environment. However, when you're talking about performance metrics, such as rates, which is inverse time, the inverse time is the thing that screws you if you're trying to average over the sum of times, for example. So that's why you have, because it's inverted, you have to use essentially kind of an inverted arithmetic mean. That's the harmonic mean.
Okay, I'm going to have to sit down with you. And no, because this is something. This is why I want to talk about these topics, because I think a lot of these things are not intuitive to a lot of us who haven't dealt with it at a deep level.
It's intuitive at all.
Sure.
This is actually painful, and
Sure.
by no means obvious. And the other thing I was trying to get at was that if you look at the general sort of statistical tools and statistical literature, this will never come up, because when they say mean or average, they mean statistical mean, which turns out to be arithmetic average. But you're going to have the harmonic mean, you're going to have the geometric mean, you're going to have the golden mean. There's all sorts of other ways of averaging.
I see.
The only reason this crops up in performance analysis is because we're sometimes faced with a situation where we're trying to average rates, i.e. inverse times quantities, and that's where we run into problems. Okay? Otherwise we'll get the wrong averaged metric at the end of the day if we don't do the right kind of transformations.
Okay, so tell me when I have a slide on rates here, and I thought I was thinking about this correctly, but please let me know. I was finished with this StatsD example. So StatsD, is giving you its per second rates, and so does CollectD when you set in CollectD 5.0 when you set the store rates as true. It does it pre-derives counters for you, so you have a per. It pre-derives counters and does the same thing as StatsD, where it divides by the flush interval. So you end up with a per second rate for, say, a rate of bytes per second, something like that. Dieter?
For what it's worth, StatsD actually stores both of them. So in your main namespace, it will store the rates.
Right. So I'm only familiar with StatsD from a few months back before there were some major changes in the namespacing. So StatsD originally, this is why it was somewhat confusing to people, because they would be looking under the stats tree. So there were two trees that StatsD would populate. There'd be stats, which would have both your latencies and your counts, and the counts would be this per second average. I think that's correct. And stats counts would be the actual raw count, so the raw count per flush interval. So this, I don't know really anything else that goes in this category, so I'd love people to shout out other things that are appropriate for summing. So actual raw counts, if you're talking about counts per your interval, those I think are most intuitive to be summed when they're aggregated. So when you're looking at your 10-second lead metrics, you had 10 hits in that 10-second period. When you roll up to minute lead metrics, you expect to see 60 in that column because you're at per minute counts. In derived counters, I mean just straight. So I'm most familiar with collectd for a polling recorder of data. And some of the older collectd plugins before they officially supported Graphite would do the pre-derived values, but they would do it at that collection interval. So your per 10-second, per 60-second derivation of actual ever increasing counters. Min and max. An alternative to averaging the min and max from StatsD or from other things, you could also take the min and max if you're more interested in what the actual min or max from the original aggregation was for that period. This is one of those things where you need to sit down and think and make a decision on what makes sense for you and your use case and your retentions. And latest, I think the only thing that makes sense for latest is if you're actually storing raw counter values. So you're storing the counter from your network interfaces, TX received or something. Storing these, you're going to end up generally deriving these things at usage time. I tried to think a little more deeply about this the other day. I think you get, if you ended up averaging these counters, I think you get somewhat same value, but I don't think they're correct, quite correct. Like if you actually were to try it up to, if you averaged all of your counters and then rolled them up from 10-second lead to minute lead, I'm not so sure that your actual byte count would be accurate. But I'd love to actually sit down and write it out for someone. For me, a lot of this stuff requires me to sit down with a pen and try to write out what's actually happening here. And here's an example of where we configured this in Graphite. So this is storageaggregation.conf. We're doing this all based on just namespace matching, just like storage schemas. And at some point, storage schemas and storage aggregation will be merged into one file, because these are very similar definitions, and they both influence the same file creation of these Whisper database files. But so in this case, we do matches like most of the things that are providing us data in this way. If they're taking extra data like upper or lower or percentiles, they'll put it in the namespace itself as separate metrics, so we can just match on those. So this is where I get the per second rates. So we don't have any other options than straight arithmetic average. So we could explore some if appropriate. So I would like to understand this a little bit better. So I think part of the point of doing this, though, is that if we want, if we take these per second rates, we can, if we multiply by the actual number of seconds in our buckets, we get what the count was per that bucket. And I think that is correct. But I would love to be corrected on that. So if we have our minutely rollups, and we know we're looking at our minutely rollups, and we have these per second rates, if we multiply by 60, then we get the count per minute in this case. Now, if we multiply by 60 and we're looking at 10-second lead metrics, we're going to get I believe the per minute rate average over 10 seconds, which doesn't quite mesh in my head. So be careful with these things, but what I want you to do is to be thinking more deeply about these as you use these. So enough about these roll-ups here. I want to talk about another gotcha with Graphite is the render time consolidation. I've seen a few examples of how other rendering libraries have done this, but I'd love to see more. Right now, what Graphite does is if there are too many points, Graphite averages those points to make sure that we don't have more than 1 point, basically 1 point per pixel. I think the actual value is per 1.2 pixels or something. But so as you see the top, this is Etsy's Holt Winters confidence bands applied to a metric. As you can see, the top is quite messy, and you may prefer this. There's There's a render time setting called, it's in the x-axis menu for point width consolidation threshold. Is a crazy name. If you set that to 0, you'll turn off all consolidation, and you can get this graph if you like. And that's all I've done to generate this. So what we actually see by default when we render this is we actually see like the discrete lines here, and these values are averaged. And so they're averaged just enough to fit it on the graph. So the first question people always have here is, well, I zoomed in and I see this big spike, and it spiked to 17.5K, and so this is say a count. And then I zoom out, and now it's like 12K. Like, what happened? Well, we averaged it. We averaged it to zoom out and show you that trend. So how do we deal with this if we actually do want the discrete values? So I generally average, again, this is like the most common use case. We generally are looking for trends. We're looking at a dashboard full of metrics, and the first thing we're interested in is that there is a spike, that there is something that looks funny to us, to our eyes. But in some cases, we actually are interested in seeing where that value plots on the graph. So there's a few options. So we can influence the consolidation that is done. We can change from average to, say, sum. But like, look at the sum here. Now all of a sudden it's 35K. Well, the problem with the sum is that we don't know. Like, this is the sum per what? It's not exposed to us. This is just part of the rendering. So some actually, there's actually a shortcut method in the render documentation called, I think it's just called consolidate. So this is consolidate by and passed in with sum as a parameter. So I feel that doing a consolidation with sum at this stage is not very useful. If you're just looking at spikes, max perhaps does make sense. And max does, if we go back and forth here, max does give you approximately the same range as you had had before. Of course, if there were some spikes, downward spikes, you would be absorbing those now. We also have min, and I think it's just min is the other option here. So instead, my preference is to use control the granularity directly. So this is I think this is a daily rate, a daily graph. So this is a summarize over 10 minutes. So then I know that this value, I've prevented the render time consolidation from happening because I've reduced the number of points that are actually being displayed, and I've decided that 10 minutes seems to give me about the graph that I want. So when I design my daily dashboards, I maybe state in the title of the graph, this is the 10-second count of something, or the 10-second average of something. The summarize will default at sum because it's summarize and it's a pun. But it will also take min-max latest average as options. So this is my personal preference is to especially when we're talking about design dashboards. People probably are going to notice the values when they look at them. So decide on the granularity that looks good and that works with your data, and name it appropriately so that it's explicit what you're looking at. And that is about all I have. So again, just to recap, what I want is for people to be actually like thinking about the stuff as they use it. I think a lot of users are caught by surprise by some of these behaviors, and I think that Graphite could ultimately deal with a lot of this stuff a lot better. But I want everyone to be at least trying to reason through the interpretation of their data, what their data is actually reflecting, and how it's going to be rendered and displayed and rolled up. So that's all I have right now for presentation. I would actually like to get some people up here to tell stories. So, Dr. Neal, I don't know if you found my explanation of rate of rate as to whether that was correct to multiply those to get my per bucket rate. Okay.
I'm not suggesting as long as it's trivial, it's
And that's what you find dealing with these systems is, I mean, I don't have any sort of statistical background. My background is with the project, and that's how I've learned.
The weird thing is you won't find this in statistical background, it's outside of that. That's the one of the.
That's very interesting. That's very interesting.
It's cerebral work. Once you get it, then you'll understand what I'm saying. And
Right.
You just have to look for it, and if you're putting metrics together in such and such a way when you're averaging rates, you'll know what to do. So
Right.
it's like a small learning curve, but it requires an effort.
Sure.
It's not intuitive, it's not obvious, and it's not something that's normally discussed even among statisticians. They don't talk about this stuff.
Right. And ultimately, I think in general, where I would like to see the project go is to make some of the stuff that isn't intuitive, and a lot of this, what I've presented, is not immediately intuitive to people who aren't familiar with this. To make it more intuitive, or at least exposed to users, so that they're at least prompted to reason about it and try to reason about it. Because what we're trying to do is we're trying to view our data, and if we're not understanding exactly what the data is, then we're kind of lost in the sea there. So I had,
Any algorithm that involves something like that gets embedded somewhere, it's the wrong thing. That's actually not forever.
right, exactly. We need to know exactly what is being done to our data. And to your point earlier yesterday, we are losing a lot of data when we do these roll-ups, which is one reason to avoid doing too many roll-ups, because you lose quite a bit of data when you're averaging. And right at this moment, we're not doing anything else to record some of the distribution of the original data. So, go ahead.
Just a question, is it possible to do median or other percentile?
It would be certainly possible to implement. In the case of roll-ups, it doesn't quite make sense to, I don't think, since we're generally rolling up, we're generally, unless we're doing something like these daily roll-ups, we're generally doing small step changes. So we're going from these 10-second lead to minutely, or from second lead to minutely, or minutely, maybe minutely to hourly. It could start making sense. But like if we take the median from our minutely, or our 10-second lead to minutely, that's not all that meaningful. And they're all going to be, I think we would generally be doing like an imputed median, where it's not an actual value that was present. I can't remember the methodology. So we do have tools in the functions to get medians, like moving medians and things like that, if we want to do that from our longer term data as a means of consolidation. Oh no, it's not a consolidation. It's a means of smoothing, I guess we would be talking about. Now, median certainly makes sense as far as something like StatsD, which is doing aggregation of a very large number of values, or a library that's running in your app that's going to coerce everything into these buckets. Then that's a strategy for losing less data, is to record things like our percentiles and medians. And sometimes that's more useful than viewing something like an average, especially when we're recording that data for posterity, or at least for near term. So, you had something?
No, Scott.
No?
Yeah.
Okay. Go ahead.
Can you talk about, or maybe explain why, like taking the non-negative derivative of a counter, and then if you zoom out to look at a larger time span, I guess because it's maybe another archive, why that seems to change where the value is.
So the question is when we take a non-negative derivative, so we could take when we have raw counter values, we take a derivative to actually get the count per period. And most people use a non-negative derivative because non-negative derivative will basically ignore rollovers and not show a giant negative spike when we have a counter rollover. And it does actually, most people don't use it, but it does actually take a counter maximum. If you know the maximum of your counter, you can pass it in to account for a little bit more intelligently to that rollup. So the question is when we take a non-negative derivative at a final resolution, and then when we zoom out and reach another archive, something funny is happening to our graphs. I suspect, and this is, again, I haven't fully reasoned through this myself, but I suspect that this is a consequence of averaging those raw counter values. I think we're losing some information, or I'm not sure exactly what is happening. I expect that if we were to change that roll-up to use latest, when we reach those, so what happens if we have, say, our raw counter values stored every 10 seconds, and then we have our roll-up to minutely as taking the latest point. That means that at the end of the minute, at the end of those 10-second samples, we're going to record what the raw counter value was at that minute. If we were only sampling on a minutely basis, that's the same value that we would have. Right? We wouldn't have the average of all those values, and the average is going to be the average. I'm not even sure what the average means. So, in this context. So I would suggest if you're storing, I prefer to store pre-derived values for counters. I find it's more convenient since you tend to be taking derivatives to view anything anyway. In this case, I'm not disagreeable to the attitude that it's a form of loss of information. We want to actually store that raw counter value. That's a valid argument to make. I think the correct strategy, though, for roll-up is to take the latest. But I don't know. I'm sure there are more questions here, but okay, go ahead.
So given that a lot of the time our distributions of data are not normal, can we do like medians or quantiles as like aggregation functions, or is that at all like?
All right, so yeah, we was brought up a little bit. So as far as roll-ups, I'm not sure it makes sense with such a small set of input data. When we're doing roll-ups, we tend to be doing the roll-ups from buckets of data that are oftentimes under a sample size of 10. To roll up to the next bucket, and taking the median of that, I don't think is super meaningful. That said, I mean, like, if people want to experiment, especially today, I'd be happy to show anyone how this where this stuff happens and how it works. If you want to hack on it and mess with it, I think there's a lot more that could be done as far as preventing information loss in some of these roll-ups. If we actually work through some solid use cases and see what's happening. Yeah, and again, go ahead, Dr. Neal.
One of the questions you had at gas, I found some slides where I can show you what I'm talking about.
If you'd like to come up here, I'm fine with that. I have extra time, and this is what I want to do. I want to have some story time. Have people come in here and contribute more, because I'm not an expert. I just read the code. Go ahead.
It's dangerous.
How many people are actually running Graphite in production? How many are running it in a cluster and not standalone?
Cool, it works.
One guy.
So is it working well in a cluster, or y'all finding that adding new nodes and it becomes better actually? I would love to talk about running clusters on
Do we have to do any kind of special?
I think it should be cool for however you're doing yesterday.
It's just sensing the projector right now.
Yeah, I'm not very experienced with the presentation tools and stuff, so.
I think, is it showing up or not? No, I think we have to. Don't we have to push
It's
projection?
probably on this end. I think you need to.
No.
Well,
the guy
it's not actually.
I know, but the
displaying
guy
yet.
came in yesterday, and isn't there an AV guy?
I don't know, but is
The-
Jason
the black
around?
guy? I think is it projection? Trying to-
Obscurity? No? Said he was going to be here. Go for it.
He did something like press this or something in one of these, but that's a laptop maybe.
Is one selected, right? Oh,
That's it.
sweet.
Okay. Well, this is talk about a hack. This is a hack talk, I guess. I don't even know really what the hell I'm doing up here, but it just turns out that in my classes I actually go through this, and we don't have time to go through the whole thing, and I don't want to do that. I just want to sort of see if we can get calibrated on something. But it's worth understanding where all this comes from. It turns out to be completely non-trivial, and you can blame the Greeks. So they're not only causing, problems in the Mediterranean financial system, but they're actually responsible for this stuff too. Because if you think about it, where do names like geometric mean, harmonic mean, golden mean come from? They come from the Greeks, because they're thinking about things completely geometrically. And you have to understand that people like Pythagoras, you've heard of Pythagoras' theorem, you probably used to know what it was, to do with triangles. That really comes from a kind of a almost semi-religious cult, where they believe that even things like musical tones were completely expressible as geometrical quantities, and in particular meaning rational fractions and this sort of thing. It was things like square root of 2 that screwed them up, because this was not a whole number, and this led to problems. How can the gods not use whole numbers? So that held us back for 2,000 years, actually, that whole setup. But anyway, they're responsible for this, these terminologies that I've just been throwing out: arithmetic mean, harmonic mean, geometric mean, and so forth. Where do they all come from? And just to show you the difference, I'm not going to go through the whole thing because we don't have the time to do it, but just to show you what I'm talking about, you can see there, I'm just calculating, let's see, where I've got a red rod there of length 2 and a blue rod of length 8. And you would normally think about the average as meaning the sum of those two numbers divided by 2, which actually is the centre of mass of the two rods. If I weld them together, I make a rod of length 10. And where am I going to put the fulcrum to balance it? At the point 5, right? That's what the arithmetic mean means. If you use some of these alternative types of averaging techniques, such as geometric mean and the harmonic mean, the gold mean, so on, you get different values, as you can see there, the GH, and the last one there is the golden mean. So you get different quantities, and of course this is the thing that's a bit puzzling. How else could you be referring to a mean if you're not talking about the arithmetic mean? That's just simply a bias that we have in our culture, because that's what we normally talk about. And also the statisticians in that sense are also completely biased, because they're using the arithmetic mean when they mean statistical mean, by which they mean the first moment of the distribution. They have very technical definition, therefore they don't need to discuss this other stuff, actually, it turns out. So, for example, in R, when we come to that this afternoon, there is no geometric mean function in R. There's a mean, which will take the arithmetic mean for you, but there's no such thing as a harmonic mean. You have to put that in yourself. So this all has a history which I go through talking about. Actually, I play jazz guitar, so actually the strings on a guitar are all tuned according to these kinds of averagings and logarithmic scales and all sorts of things. That's why the frets on a guitar are not evenly spaced. They're logarithmically spaced, just for so that you get the correct doubling of tones at the octave and so on and so forth. And that all comes from this geometry. So Pythagoras was actually onto something. I'm not going to go through all that. It takes too long. But there are these specific definitions, and I thought rather than going through all of that too much, I actually give quite a visual definition of all of these things. I can compare them geometrically as shapes as the Greeks intended. And you can see where the different numbers come from that way, but I think I'm going to skip that right now. Let me just go to an example. The geometric mean, by the way, comes up in, I don't know whether this audience is familiar with this, but if you go on the, anybody know what spec is? Spec.org? Clunk. So there are a couple of, or a few industry standard benchmarking organisations out there, one of which is SPEC, stands for System Performance Evaluation something or other, corporation or something like that. They keep changing their names to protect the guilty. Spec.org on the web, and TPC is the other big one, so it's Transaction Processing Council. So that they break down this way. SPEC basically measures CPU ratings. In fact, I would say that over the last 20 years that they've existed, they probably created the definition of what you might call the nominal MIPS value for CPUs today. We don't use the term MIPS anymore, but well, IBM does. But People talk about the spec rating or the spec mark or the spec rate or something like a spec number. And in fact, this is all over the place. It's even embedded in simulators and all sorts of things. So if you can reference one machine to another by figuring out what is their relative spec values. And if you go on the website, you'll see all these things listed. What I wanted to point out to you is that the spec numbers that you see as individual numbers that rate each CPU are actually derived from running, I don't know what the exact number is right now, but about 20 or so benchmark workloads that are the same for every machine, 10 of which are basically integer workloads, or so they claim, and the other 10 is floating point. And then you can take that either separately or together. But the spec number that you see on the website is formed by taking the geometric mean of those numbers. Oh. And you may then ask yourself, why? Why don't you just take the arithmetic mean? And I've heard endless academic discussion about this. In fact, I even saw John Hennessy, who's now the president of Stanford University, ranting on about how, the geometric mean was the correct prescription for taking this kind of thing and blah, blah, blah. This is actually all bullshit. It all boils down to marketing. The reason for using the geometric mean is because you have to understand these benchmarking organisations, they don't come out of a vacuum. They come out of a cartel. Well, kind of like you guys, except they have stuff to sell. That's the slight difference. So, when money's involved, the whole world gets distorted, right? So the point is, you're kind of, you're buddies, right? Because you're all making CPUs or you're making workstations or whatever the hell it was when they started out. And so, we're kind of buddies, but on the other hand, you're also competitors because you're trying to sell stuff into the marketplace. So this leads to a problem. We've got to be buddies. On the other hand, if you have a CPU that really performs way, way better than mine, well, that kind of sucks because I can't catch up to you, at least not for a while, if ever. And then how can we be buddies if you're leading the pack? So we can't tolerate that. So what we have to do is, in cases like that where we have a big variance amongst, say, the CPU speeds from different vendors, you apply the geometric mean. Why? Because the geometric mean is nothing more than the logarithmically scaled arithmetic mean. The logarithmic scaling has the effect of reducing variance. That's the reason. It's marketing. So we're talking about harmonic mean, however, because we're talking about rates. So let me just flash ahead here. I'll try to go to an example. So here's an example. See if this rings any bells. It may or may not. I'm not completely sure myself. So let's suppose we have two database systems that we're monitoring, and we record 20 million total transactions or records being processed, right? So there'll be your count in your Graphite language, or actually in any metric language. And this is done sequentially. So 10 million of these were writes that were processed at one rate, 200 TPS. That's 200 transactions per second. Rate inverse time, right? That's one of my three metrics. And the other 10 million reads were processed at a different rate, 600 TPS. So now we've got the same count, but at two different rates, because one's reads, one's writes. That's quite typical, right? Could be any IOs like that. And so another question is, what is the mean TPS rate of the server? So if we look, now the thing that we look at is that, of course, they took different times, right? Both doing 10 million, and since they're doing it at different rates, they take different times to complete the execution of that workload, right? Whereas I think what you were talking about, just to sort of come back to you were talking about maybe the same time intervals in each measurement thing, or no, that's not one that I'm not sure about what you were saying there. But anyway, that's one of the key difference points to think about. And then, so therefore the total time, if we do the arithmetic, the total time is the sum of the 13.89 plus 4.63 hours. And that comes to 18.52 hours, right? That's not right. That must be seconds.
That's right.
Hours from TPS, is that right? Oh yeah, because there's lots of records, I guess. Yeah, time flies, huh? So if we take the arithmetic mean of the throughput, which is what we would have thought to do, naturally, is instinctively, we would get 400 TPS. But the total time is 13.8 hours. So the completion time would be the same as just T1, which was 13.89 hours, whereas the total time is actually 18.52, right? So we get the wrong total time if we just take the arithmetic mean of those throughputs. Do you get what I'm saying? So same counts in both cases, two different rates, therefore two different time intervals. That's the key, right? And if you just average that out in the arithmetic way, you screw it up because you end up with the wrong total time interval. So something's gone wrong somewhere. So when you think all this through, I said it's not intuitive, right? I'm not pretending it's intuitive at all. When you think all this through, you realize that, oh, light bulb goes off, I should have taken the harmonic mean, damn it, if you knew about such stuff. So who the hell knows? The point is you try it, and it turns out it works. So, and the basic reason for this is what I said earlier, it's because we're trying to average rates. Two different rates, we're trying to find the average rate for the same counts, means they've got two different time intervals. And if you don't take that time intervals change into account, that's where it gets hosed up, because the rates are inverse time. So the reason for the harmonic mean is you can think of the harmonic mean, this is not completely correct, but it's a way of thinking about it. The harmonic mean is kind of the inverse of the, it's the average of the inverse, what did I say? Let me see. I thought I had it written here somewhere. I've got it somewhere, it's not on this slide. But you can see it's this inverse thing here?
The inverse of the average.
It's the inverse of the inverse, so that's the... And it sounds crazy, but the point is because we're adding these inverse time metrics, right, one of the three, in order to get that total time interval correct, we have to take this sort of a double inversion step. But the thing that's being added in the denominator here, this is just a summation, but it's a summation of inverses also, right? So that's kind of completely unintuitive. But if you do that, then we get the correct time interval. So that's just, I just wanted to show you that's what I was talking about. There's an example. You can kind of work that through. So now the question is, we go back to graphite or whatever the hell it is you were talking about there. And when you're sampling, when you're doing averaging for, I guess, for your roll-up or your aggregation, this is the sort of thing you've got to watch out for, because...
Yeah.
But on the other hand, if you're saying we're always looking at the same time intervals, you know, tick, 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 that's not what I'm talking about here exactly.
Yeah.
So this is.
I think what the way I've approached it is I'm looking for that 10 million number. I'm looking to see how many happened in a certain number in a static amount of time in a.
You're trying to average the count, as opposed. You're actually really trying to.
Right. That's what I'm trying to.
If we really hash this through, you're trying to average the count.
Right.
And here I'm talking about averaging the rate, which is what it sounded like you were talking about. That's why I flagged it. See, but.
Right.
So I mean, I'm not saying you're not correct, but this is just typical of the kind of thing you have to watch out for. Whether if you're averaging the count, I think what you're saying is okay, but we probably should work it through.
Right.
If you're averaging rates, then you have to do this. Otherwise, you screw up the total time interval. So that's basically what I was getting at. Just something to watch out for. And it's not easy. It's completely unintuitive. It makes me nervous. And I have to sort of think it through every time what I'm doing, and I'll still screw it up. But the point I wanted to make is if this kind of thing gets embedded incorrectly into some stuff that gets out there, that could really hose you up, particularly if you ever get to doing real performance analysis or capacity planning, you're a host. And we have enough other things that can go wrong. We don't need another one.
Anybody familiar with the gift from what's the TV show? That's what's in my head.
The exploding brain. Yeah.
Find it, but I can keep
Show your generalization.
Sorry?
You give one generalization.
Generalization. Oh, that's this stuff you mean?
Yeah.
This is the generalization of all this. I'm not pretending we're understanding this right now because we haven't had time to go through it. But the generalization is, so you take the arithmetic mean. The arithmetic mean would normally just be the sum of the numbers that you have, say counts, divided by the number of counts, right? But it could also be that, depending on the context, where you want to weight the amount of each contribution differently. There are reasons for that, which I might go into here, it's too complicated. But you can do that also. So you have different weights for different quantities that you're adding together, but then you have to take that into account as the sum that you divide by the denominator. And you can do the same thing with the geometric and harmonic mean. I'll tell you where this happens. I know for the harmonic mean, interesting enough. This is the IBM, for example. We'll talk about mainframes, right? Nothing new in computer science. IBM does a very good job of this when they facilitate mainframe owners to do upgrades with what they call CPU engines. That's basically CPUs or processors. So they produce a table. It's actually a booklet. It's called the Large System Performance Reference, and they give it to all their customers. And these numbers come from their own internal benchmarking, not SPEC or TPC. And they relate it to the kind of workloads you run on a mainframe, DB2, kicks, and all this sort of stuff. And this is the sorts of things that are typically running in a customer's data center. So they benchmark accordingly, but of course they can't cover every possibility, all the combinatorics of the different workloads of DB2, TSO, kicks, and so on, right? So they pick one profile that they think is pretty typical. And then they generate the numbers. And these numbers allow you to say, okay, I've got this current model of a processor or CPU engine, and my workload is going to increase by 20%, let's say, in the next year. I want to have 20% more horsepower. What model engine should I upgrade to? And you just basically just straight do the numerics based on this reference table, and it will point you at exactly which model number you need. This is fantastic. By the way, SPEC could do this, but they're too lame to do it. They often ask me to come and tell them what they should do next, like I actually believe that's what they want me to say. So I tell them, and then they completely ignore me. So I've stopped doing it now. But they could have done something like this because it would make it very useful for customers to do this kind of referencing. Anyway, the point is that what IBM does on top of that, as well as providing the table based on their sort of, their typical profile as they see it across all of their customers, they then give you a mechanism that if you say, for example, well, I don't run DB2. So I want to know, how do I do the upgrade when I don't run DB2 in my workload mix, whereas that's what they ran in the IBM Benchmark Center. And they show you, you can reweight the contribution so that you take out the contribution from DB2 because you're not running it. You reweight the other things that you are running, and you calculate, guess what, the harmonic mean to figure out your new MIPS rating, because MIPS is inverse time, right? It's instructions per second. So you reweight according to the harmonic mean, because you're re-averaging in a rate, so you use the harmonic mean. You're dropping the contribution from DB2 so that the W's changed, and then you can figure out what your number is and redo the calculation, and boom, figure out what the model is. Huh? Yeah, it's really quite cool. So IBM's done a very good job on that, actually. So all of their capacity planners use that reference material, and they can do these kind of calculations. And that's one example where this really does kick in a meaningful way. It's not just an abstraction. It's really used to do full-blown capacity planning. But that relies on, IBM's got it easy because they're only doing their stuff, when you're looking at all possible stuff out there. So, but that's what SPEC should do, in my opinion. But what does my opinion count? Do you have any other questions about it?
Graphite let you average in
That's-
one data point? So the way we use it, it just replaces whatever value is there if you write to it in the same time period? Is there a different way that's...
So if you write the same, if you have the same timestamp, you can write it twice.
Yeah.
So no, right now it is just going to overwrite the latest point. That's kind of one of the decisions that was made originally with Graphite, is that it's storing these data points, but it's not going to so actually, this is a reaction against RRD. So RRD, you can actually do this. You can say, at least I think, I'm actually not an RRD expert, but you can store data points and say, hey, I just stored the same data point in the same period, and RRD within the file format will actually average it for you and continue to take that new value into account without overriding everything.
Right.
It was avoided. That was avoided because it was felt that was too close to that was too far down. That was being done in the file format, whereas something that is more well suited to be done either on the client side, so or in something external.
Yeah.
The Graphite does have a component called carbon aggregator that will do that. That will do averaging of the same data point or different data points within the same bucket. It could potentially be used as like a replacement for something like StatsD. Its purpose is more though for summary metrics.
So it's more as like as a pass through where you're sending, say, per machine metrics. So for instance, one concrete use case. So I'll get back up. Thank you very much, Neil. And I know, sorry, I know we're right out of time here.